Hi guys, it's Ian here and welcome to today's live session and on this session we are looking at averages. Okay, so I'll just write that down there. Okay. Hi guys, it's Ian here and great. Welcome to today's live
Sorry
session.
about
that. That's just my sound test. Okay, perfect. Right, so let's begin. Averages in Functional Skills Level 2 involve a few things that include the mean, the mode, the median, and the range. Okay, so these are 4 words that you need to know, and you need to remember what each one is. So what I'm going to do is, before we get started on any exam questions, I'm just going to do a quick recap of what these 4 things are, and then we will begin. Okay, so in order to demonstrate these best, I'm just going to put together a collection of data here. So I'm just going to write down some numbers. So let's say I've got 4, 3, 4, 7, 2. Okay, so I've just got 5 pieces of data here. Okay, and these could be anything really. They could be the number of shoes that people have, well, the number of pairs of shoes that people have, or anything. They could be the number of children people have, they could be the number of family members, whatever they are. I've just got this collection of data, which is a list of 5 numbers. Okay, so if I want to find the mean, okay, the mean is the average which we think of as the average, okay, and this is where we add everything together, and then we divide it by the number of things. So in this particular case, I would be looking at doing 4, add 3, add 4, add 7, add 2, and then I would divide this by the number of pieces of data that I've got, which is 1, 2, 3, 4, 5 pieces of data. Okay, so I would then divide this by 5. Right, so let me get out my calculator and then we can work out what that is. Oh, it's on scientific mode. Right, let's put it on basic. And then let's put that over here maybe. Where does that go? Oh yeah, that's nice. Just down a little bit. Okay, so let's do 4, add 3, add 4, add 7, add 2. Okay. Oh, that's nice. So this equals 20. And so that's going to be 20 divided by 5. Remember, if you don't see this line very often, this line that we see here, it makes something look like a fraction. That line actually always means divide. So this, when I write this out, the mean equals, add everything divided by the number of things. Okay, that line means divide. So I've got the top equals 20. So I'm now going to do 20 divided by 5. And let's see what that gives us. 20 divided by 5 equals 4. Okay, right, that's great. So that is the mean, okay? So there's actually, I will, once I've gone through the mean, mode, median and range, I'm going to quickly go through an example of mean from a frequency table, because that is the other one thing that we need to know when it comes to averages for functional skills. Okay, right, so that is the mean. Now let's look at the mode. Okay, so I'm going to delete all of this and we can look at the mode. So the mode is the most common, okay? Okay, and let me write that again. Mode, okay? So the mode is the most common. People try to remember it by thinking of MO as, so MO is like most, mode, most, mode, most. I don't know. It sometimes works, okay? We can also hear the mode referred to as the modal group, okay? And the modal group is when a group is most popular. Okay, but for our data that we have here, we're looking at the mode and we're looking at it for the most common. So what we need to do for this is we just need to look at our numbers and see if any of them appear more often than the others. So I can see here that 4 appears twice. So for this group, the mode equals 4. Okay. What I'm going to do now is I'm going to quickly get rid of that mode of 4 and I'm going to tweak the data a little bit because I want to take you through an example of what actually, let's go and do so I can unhighlight them as well. There we go. Because I want to take you through an example of what happens when there's more than one most common item. So let's say I've got another number here. Let's say that I've got another 3. Okay. So now what we find is that there are 2 numbers that are, just move that out of the way for a second. There are 2 numbers that are the most common. So now we've got the 4s, okay, but we've also got the 3s, okay. Now if this situation occurs, we would say that the data is bimodal, okay, bimodal. Okay, bi means 2. So bimodal is going to be 4 and 3. So there's 2 modes this time, and this is bimodal data. Right, let's get rid of all that again, and let me adjust the data in a different way. Oh, 1 second. Okay, let me adjust the data in a different way. And let's say I just get rid of this 4 altogether. Right, now, in this situation, we've got the same number of every single item. So with this one, what we would say is we would say that there is no mode, okay? If all the data has the same occurrence, then there's not going to be any mode. So that's no mode there. Okay, great. Let me just quickly show you what I mean by this phrase modal group. Okay, so let's say I have asked people their favourite colour. Okay, fave colour. Okay, and people have said red, yellow, blue. We always cover the most exciting of surveys in functional skills maths. And we could say here that we've got a frequency. Okay, frequency means the number of people. And I could say that the red had a frequency of 20, the yellow had a frequency of 34, and the blue had a frequency of 17. So in this case, the most popular group, the mode of this data would be the yellow, okay? Because most people like it. So the answer to this question though, the mode is funny. The mode is yellow, okay? It isn't 34 because we're not really interested in the number 34. We're just interested in what the favourite colour is. So the mode of this data would be yellow. So if you're asked what the modal group is, for this, you would say yellow. And you can also think about this as if I'd written this data out in a list. So say for example I've got red, okay, someone had said yellow, someone had said yellow, someone said blue, someone said blue, someone said red again, someone said yellow again, someone said yellow again, someone said yellow again. Remember, whenever we have a table, that table of data has essentially come from a list. And so the reason why mode is yellow is because in that list there would be more yellows, okay? Right, so we've done the mean. The mean is everything added together divided by the number of things. We've done the mode, which is the most common. Now let's look at the median, okay? So let me get rid of this data here. Okay, so there we go. So get rid of this. And I'm going to change this back to how it was, okay? And I'm now going to talk about the median, Okay, so the median is the middle value when data is placed in size order. Okay, and it's difficult to remember the median. It doesn't really have much going for it to help us remind us of it, but you could kind of think as the median, the middle, it's the middle value. I don't really know if that helps at all. Hopefully it does, but median, middle, I guess it's got an M, it's got an I, it's got a D, it's got a lot of the same letters. It's actually got an E, but it's in the wrong order. So the median is the middle value, okay? So always remember that the median is the middle value when the data is placed in size order. Okay, so let's first of all place the data in size order. So from here, I've got 2, okay? I'll just tick it off when I've done it. 2, 3, 4, 7. Okay, so here we go. We've got 7 pieces of data here. No, we don't. We've got 5 pieces of data here, and we've put them in size order. Now, let's look at that. 5 pieces of data. Okay, 1, 2, 3, 4, 5. Okay, so I can see here that the middle, I can see clearly, because it's quite a small data set, that the middle value is 4. Okay, so that's the median of this one. So the median equals 4. Now, I'm going to show you a method for identifying the middle number for when you have more numbers, okay? So I knew here that the middle number was 4 because it was in the middle, and I could see clearly that there was 2 pieces this side, 2 pieces this side, so 4 is definitely in the middle. Sometimes it's not so easy to identify the middle number. So when you can't identify the middle number, what you do is you do pieces of data, add 1 divided by 2. And let me show you how this works. So the middle equals the pieces of data, add 1 divided by 2. And so this works like this. So if I've got here 5 pieces of data, I can do 5. Then if I add 1, I add 1 to that, and then I divide it by 2. Now this equals 6 divided by 2, which equals 3. So that tells us that the middle, in fact I should be really clear here, the middle position is the 3rd piece of data, the 3rd position. So there we go, we can see that with here, 1, 2, 3. Okay, 1, 2, 3. Right. Okay, this is all very well and good for when we have an odd number of data, but what we need to do is we now also need to look at when we've got an even number of data. So let me just delete all of this bit here, delete this here. Actually, I'll just delete this as well. I am going to just minimize this bit here just to keep it in the corner. Okay, let me shrink this, and we'll just remember that there. And then I can get rid of this bit here as well, because that's going to be misleading to us later. Okay, so what I want to do is I am going to write out a new set of data. So let's have 2, actually let's stick in some decimals just to make it interesting. 2.5, 3.7, 4.9, 4.2, 3.4, 1, 2, 3, 4, 5, 2.6, 3.8, 1, 2, 3, 4, 5, 6, 7, and one more, 9.2. Okay, so here we go. So the first step always, when you've got your pieces of data for the median, is to put them in size order. So let me have a look at what I can find. It looks to me that 2.5 is the smallest. So I'm going to write that down first. So we've got 2.5. Then I've got 2.6. Then I've got 3.4, 3.7, 3.8, 4.2, 4.9, and 9.2. Okay, now let me just count these to check that I've definitely got the same number that I've started with. So this is my first piece, first, second, third, fourth, fifth, sixth, seventh, eighth, excellent. 1, 2, 3, 4, 5, 6, 7, 8. Yep, so I've still got all the data there, so that's wonderful. So now I know what I need to do is I need to identify the middle piece of data. So the middle position is going to be 8 because there's 8 pieces of data. Add 1 and then divided by 2. So 8 add 1 is 9. So we've got 9 divided by 2. And 9 divided by 2 equals 4.5. Okay, right, now this is interesting because it's an even number of data, there isn't actually a piece of data in the middle. So I'm going to put a line here to indicate where the middle is. So as you can see, we've got 4 pieces this side, 4 pieces that side. So the middle is, as the calculation showed us, this 4.5 position. Okay. Now the way that we do that is we basically find the mean of these two. So we find the average of these two. So what we're going to do is we're going to do 3.7 add 3.8. Okay, so that's both of them added together, divided by how many of them there are, which is 2, and that will be our answer. So let's do this on the calculator. Yeah, so we've got here 3.7. Oh no, that went wrong. 3.7 add 3.8. Okay, and that equals 7.5. And then we're going to do 7.5 divided by 2. So divide that by 2. 3.75. Okay, great. So that tells us the median of this piece of data. Okay, so what's important to know is that the median is also a type of average. So if somebody asked me, I've got rid of the old sets of data now, but if somebody asked me what the average was of this set of data, offering them the median is a legitimate answer. Offering them the mode is a legitimate answer. And offering them the mean is a legitimate answer. So often in functional skills, sorry, I did this last time, the heating just got too much. Okay, right. So because in functional skills, one of the questions that we often find is people having little disagreements. They're like, so-and-so thinks that the average of this is this, but so-and-so thinks the average of this is this. And the answer usually is that they're both correct, but one of them's decided to use the median and one of them's decided to use the mean. The reason why people use the median is because it can eliminate outliers. So if we look at this data here, there was this 9.2, okay, where that 9.2 is quite large, a lot larger. In fact, it's twice the size of almost all the other pieces of data. So if we had found the mean of this, then that would have influenced it. Okay, right. Okay, let's do the range, okay? And then what I'm going to do is we will look at some exam questions and we will cover the mean from a frequency table in the exam questions. And if you do want more practice at mean of from a frequency table, I've got a complete video on it, which you can find the link to in the description. Okay, but let's move on to the range. Okay, here we go. Oh, there's the data. There it was. So there we go. So this one, we could see that. So this data set, we've found several averages for it, haven't we? We found that the mode equals 4. The mean was 5. And the median was 4. Okay, let me just delete all of this. Okay. So here we go. We found that the mode is 4, the mean is 5, the median is 4, and now we've got this last one, which is the range. Now, the range isn't actually technically an average. What the range is like quality control. So the range tells you how good is your data, okay? So the range says, how good is the data? And a low range means reliable. A high range means unreliable. Okay, but what I should probably do is tell you exactly how we calculate the range. So the range is the highest value highest value, take the lowest. So in this case, we're going to have 7 take away 2. So this data has a range of 5. So that 5 doesn't tell us anything about the numbers that we have. All it tells us is whether or not how spread out the numbers there are. So we know that the highest value take away the lowest value is 5. So we know that all the numbers there have a spread of 5. So, and this is useful because it allows us to kind of know a bit more about the whole data set from looking at the mode. So if I know that the mode is 4 and the range is 5, well, depending on how the data is set out, that means that the mode, the highest value can't be any higher than 9, because if the data only spreads over 5 numbers, then if one of the numbers is 4, it would be impossible for the highest number to be more than 9. The mean, well, interesting. Yeah, the mean and the range. Yeah, so the mean tells us that if the mean is 5 and the range is 5, the range is usually like pretty much like either side of the mean, because the mean is everything added together. If you had a low mean and a really high range, that would suggest actually that the data wasn't very consistent, and it would mean that the mean isn't actually very representative of the data. One of the things that one of the examples that people always like to use for mean and range is average salaries, okay? Because there's some people that earn so much money, but most people earn around the same money. Whenever you take an average salary, if you use the mean, it makes it look like everybody is much better paid than they are, because the limits on how much some people earn is endless. But there is a lower limit to how much people earn if you're talking about people in full-time work. So it makes the data, if you use the average for salaries, then it's very skewed. Okay, but so in that example, you might actually want to use the median. So here we go, we've got the median here. And in functional skills maths, there is a particular task which is comparing the medians and comparing the ranges. Okay, so and when you compare the median and you compare the range, you are basically saying who has the higher median, who has the higher range. So the question that you might get for that is, company A, okay, median salary equals £15.24 an hour. Range equals, I don't know, £12. Okay. Then we could have company B. So here we go, let's just change that. So we could say company B, median salary £12 per hour. Range, £72. Okay, so what we could see is if we looked at these two, if we were asked to compare these, what we would say is we would say company A has a higher median salary, but the salaries are more consistent as they have a lower range. Okay, or you could say company B has a lower median salary and a higher range. And you would say, therefore, the salaries inside company B are less consistent. Okay, right, so I've talked for long enough. Let's get started at looking at some of these questions. Okay, so this is the one I wanted to do first, I think. So here we go. Let me just rotate this and then I will move on. So here we go. PDF. Here's a list of numbers. No, I didn't want to do that one. This is what I want. Remember, I've got these. So if you ever need practice exam questions split up by topic, I've grabbed these exam questions from marsacademy.com. Mars Academy. I think it's .com or .co.uk. It's one of the two. So try out that if you need to. Otherwise, if you want more practice at just using the techniques as well, make sure you visit the Crack Maths website. I've got loads of sheets and loads of questions where you can just kind of like repeat and practice your skills, okay? But if you want the genuine exam style, these are the thing that what Mars has done. She's got them from the actual exams. So for Crack Maths, great for repetition, great for practice, great for doing all that. I would definitely recommend it. But if you want to see the exam, the ones that have been in past papers, Mars Academy is a great place to go to. Okay, right, so let's have a look at this question here. So this question says that Zach looks at the weather forecast. The table shows the highest daily temperature forecast for the next 8 days. The median of the 10 temperatures is 17.5 degrees. The 10 temperatures have 2 modes. Use this information to find the forecast for days 9 and 10. Okay, I put this one up because I did see this question, and it's just an example of how we can know what the mode is, we can know what the median is, but sometimes we've got to use these in different contexts. So this question really is all about thinking, okay? So first of all, we do need to remember what is the mode and what is the median. So I'm going to say here, I'm just going to remind ourselves that the mode is the most common and the median is the middle when in order. Okay, so what have we got here? So we've got here, we've got here these 10 temperatures. The median of the 10 temperatures is 17.5. Right, okay. The 10 temperatures have 2 modes. Right, so what can I see? I can see that the mode currently is 15. Okay, because there's 3 of them. I can see that here the other number that's getting there is 19. Okay, so it's likely that one of the other modes, one of the other numbers is going to be 19, because that's what's going to get us to having 3. Because otherwise the 2 numbers here will be the same. So what I'm going to do is, with this, it might be that there's a collection of different answers that we could have. So, but what I want to do is I'm just going to temporarily put 19 in as one of those and say that we now know that the temperature has 2 modes. Now, I'm just going to put this number here as x. And I'm going to put these numbers here in order, okay? So I've got here 15 is the smallest. Well, there's 3 of them. 1, 2, 3. Then I've got a 16. Then I've got a 17. Okay, let's tick those off. Right. Okay, so I know something now. I know that this number, the 17, is in the 5th position, okay? Now, when we have 10 numbers in a row, I can see here that the middle 2 numbers are the 5 and the 6. Is that right? Because, well, let's have a look. Is that right? 1, 2, 3, 4. 1, 2, 3, 4. Yes, so the middle 2 positions are the 5 and the 6. So here, if I've got here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If there's 2 positions in the middle, this is the 17, this is going to have to be our other value here. Because the middle 2 numbers have to make a median of 17.5. Which means that, this is going to look confusing, it's going to look like algebra, but just bear with me. So I've got 17, add this extra number. Okay, I'm going to use a question mark because people often find that less intimidating. 17 plus the extra number divided by 2 has to have the median of 17.5. Remember, when we don't know the middle number, the way that we do it is by adding the 2 middle numbers together and dividing it by 2. So 17 plus something divided by 2 has to equal 17.5. Now, remember, I talk about this a lot, it's our reverse calculation. If 2 numbers multiplied together to make something, then that number divided by one of the other 2 equals the other one. So say, for example, I always use the example of 3 times 4 equals 12. So if 3 times 4 equals 12, 12 divided by 3 equals 4, and 12 divided by 4 equals 3. So I know here that something, something, ignore that it's this 17 plus question mark, but some number divided by, some number divided by 2 equals 17.5. Therefore, if I think about this, if something divided by 3 equals 4, well then that means that this times this will equal that something. So let's bring out the calculator for that. So 17.5 times 2 equals 35. Okay, so we can check that as well. So I'm going to put 35 here. So let's test that. 35. Oh, sorry. Sorry, guys. Right. 35 divided by 2 equals 17.5. Right, so we know that these 2 numbers in the middle have to add up to make 35. So therefore, if 17 plus something equals 35, then that's going to be, we can find that out by doing 35, take away 17, and that equals 18. So we know that this last number here is going to be 18. Let's just double check that. 18 add 17 is 35. Right, so there we go. So that is that done. So I'll put that there. Day 9 is 19. Day 10 is 18. They didn't specify which way around they had to be, so that's fine for us to put them either way. Okay, great. Right. Let's now look at, so that was a nice example of a mode and a range. Okay, let's now go to a mean question. Okay, so here we go. I was talking about this one because we did a brief example of the mean, but actually, funnily enough, the type of mean questions that are in the functional skills exam are actually mean from a group frequency table. I don't know, I'm getting rid of my calculator because I'm going to need that. I'm not going to do this one. I'm going to do one without a table here. Okay, so, sorry, what's that? I'm just going to take the top off. Right. So, let's have a look here at this one. So, Emma is a recruitment manager in a large company. She has this information about the number of workers in each of the 20 offices of the company. Emma estimates the mean number of workers in an office as 30. Okay, so let's have a look at how that goes. So here we go. We've got our table here. We've got this bit here which says the number of workers. So we've got 1 to 20, 21 to 40, 41 to 60, and 61 to 80. And then we've got the number of offices. So this means that 9 offices have between 1 to 20 workers. So that could be like one of those offices has 12 workers, one of them has 2 workers, one of them has 17 workers, one of them has 16 workers, okay? But whatever it is, we know that for these 9 offices, the number of workers in each of those offices falls between 1 and 20. The next bit we've got here, 8 of the offices had between 21 to 40 workers. And so what that means here is we could know that they might have 23 workers, they might have 27 workers, they might have 39 workers. Whatever it is though, these 8 offices all have between 21 to 40 workers. Right, the next one here that we've got 41 to 60 workers, and there's only 2 offices with that. And then this last one here, we have got between 61 to 80 workers in each of these offices. Okay, so you'll notice that Emma estimates the mean. She doesn't calculate the mean. She does calculate the mean. In fact, actually, she does a lot of calculations in this one. But she estimates the mean because she doesn't actually know the number of workers in any of these offices. So remember, the mean equals everything added together divided by the number of things. So in this case, she's looking for all of the workers added divided by the number of offices, okay? So here we go. We've got, so this is total workers divided by total offices. Okay, let me just, yeah, there we go. So that's what we're looking for. Now, I started talking about this estimate, then I moved on. The estimate comes in because she doesn't know the number of workers in any of the offices. So we've got to estimate it. And the way that we estimate that is with a thing called midpoints. And this is essentially, again, kind of finding the mean of the 2 numbers in the interval. So if we know that the lowest number in this interval is 1 and the highest number in this interval is 20, then we just kind of take the mean of those by doing the lowest, sorry, I did it the wrong way around, by doing the lowest, add the highest, and then dividing that by 2. So if I do 20, add 1, that equals 21. And then if I divide that by 2, what that gives me is 10.5. Okay, so Emma is going to estimate that these 9 workers these 9 offices all have 10.5 workers. So what I'm going to do is I'm going to do 9 times 10.5. Okay, and I will work that out here. So we've got 9 times 10.5. And that equals 94.5. So basically, we've estimated that the first 9 offices have 94.5 workers in. Right, now we do the same for the next bit. So we're going to do 21, add 40, and divide that by 2. So if I've got 21 here, add 40, equals 61, and then I'll divide that by 2, 30.5. So I'm going to estimate that these ones have 30.5 people in. And so I'm going to do 8 times 30.5. So 8 times 30.5. And that equals 244. So those 8 offices have 244 workers. Then we'll do the same again. So 41, add 60. Okay, and then divide that by 2. So we've got here 41. Add 60. That's add 40. Add 60. Divide by 2 equals 101. Divide that by 2. And that's going to be 50.5. So then we'll do 2 times 50.5. Right, that's going to be 101. Because we just kind of divide that by 2. So, and then lastly, we've got 61, add 80, divided by 2. Okay, 61. Add 80 equals this. Divide that by 2. And that's 70.5. Okay, so we've got 70.5 things for the last one. So now, if I add all of these up, we've got our estimate of the total number of workers. So I've got here 70.5, add 101, add 244, add 945. Let's just check. Oh, no, that's not 945. It's 94.5. Right, 1 second. It's always good to double check these, especially if you've got bad handwriting like myself. So here we go. So we've got, if we add all these up, and that equals 510. And that looks about right. Roughly 100, roughly 100, roughly 200, roughly 100. So there we go. We've got 510 workers estimated in the offices. Right, 510 workers estimated in the offices. And we've got 20 offices here. That looks right. So we're going to do 510 divided by 20. And so let's divide this by 20. 25.5. Oh, okay, right. Emma estimates the mean as 30. Is Emma correct? 30 is quite a long way off 25.5. But she has estimated it correct to the nearest 10, according to our estimate. And we have made estimates. So I'm still going to say no. I'm going to say no, the estimate of the mean should be about 25.5 workers. Okay, and I think that would be a fair conclusion. Right, I know that I advertised these sessions as 45 minutes, but I feel like I haven't quite covered an example from each one. So I'm gonna, if you've got time to stick with me, I'm just going to go through a comparison of the median and range. Okay, but if you need to go, that's fine as well. I do have a video on that. You can find it in the link in the playlist on averages. But other than that, I'm gonna see if I can dig out an exam question on the median and range now. Okay, so let's have a look. Here we go. I think this is a nice one. So here we go. I can get rid of my calculator as well. Okay. Right, so let's have a look at this question. It says, Jessie writes a report about the number of shoppers at a shopping centre. She writes down, last week, we were only open for 6 days because of a bank holiday. Oh no. This is comparing the mean and the range. Well, okay, it's the same kind of thing. So it's still worthwhile. Last week, we were only open for 6 days because of a bank holiday. The mean number of shoppers was 21,000 a day, and the range was 19.5 thousand shoppers. Jessie has this information about this week. Compare this week and last week using the means and the ranges. Okay, fine. So that means we have to find the mean of this data. So remember, the mean is everything added together. Divided by the number of things. Okay, so this week then, it is 7 days. And then we can add these together to find out the total of the number of shoppers. Okay, so hold up, this is a non-calculator question. This is a bit mean. Right, okay. But I guess I best do it without a calculator, if that's what it's saying. So, right. Let's see if we can pair up any of these numbers to make it nice. So 15.4 and 39.6, I reckon they're going to be a nice pair because 4 and 6 add up to make 10. So 15.4 add 39.6 is going to be 0, 1, 15, 1, 5. So that'll be 55. Let's add some more together. I reckon 12.5 add 17.3 add 26.2 is going to be quite nice. So let me do those. 12.5 add 17.3 add 26.2. So these three add up to make 10. These add up to make 15, 16. And then 4, 5. Okay. Right, then we've just got these last two. We've got here 19.8 add 31.6. And that's going to be 4, 1, 10, 11, 5. Okay. So we've now got 55 add 56 add 51.4. Okay, and then this is going to make 4, and then this is going to make 6, 7, 12, 12, and this is going to make 5, 10, 15, 16, 162.4 over 7. Okay, this is a very mean question for non-calculator. So I'll do this, 162.4 divided by 7. So it doesn't go into 1. 16, it goes in twice with a remainder of 2. 7's into 22 go 3 times with a remainder of 1. 7's into 14 go twice. So therefore we've got a mean this time of 23.2 thousand. Okay, so the mean is 23.2 thousand shoppers. And let's work out the range. So the range, remember, is the highest take away the lowest. One sec, I'm just going to delete this. And then move this up here. Okay, just to make some space. So we've got the mean. And the range will equal the largest take away the smallest, which is going to be 39.6 minus 12.5. Let's work out that. 1. So that's 27.1. And then we would say, okay, the range is, so this had a range of 19.5 thousand and a mean of 21,000. Okay, so if I'm gonna write an answer for this, I can see that week A, oh, I've spelled week wrong. Week A has a lower median and a smaller range than week B. Okay, I wanted to do that because that is the comparison. We can't really say much else about the data other than that. That's as it is. Okay, great. Right, well, thank you very much for joining me in this lesson, and make sure you tune in on Thursday. We're going through another past paper, and if you have any questions, any comments, any suggestions, feel free to leave them in the comment section. I'd be greatly received. Or if you have the chance just to like the video, that'd be fantastic as well. Okay, great. Well, thank you so much, and I will see you hopefully in another video. Bye.